Hello everyone, welcome to our lesson 3, and this is about application problem and finding approximate values of trig expressions. So we will discuss a couple of application problems from 6.2, and then there are some practice homeworks as well on that, and some calculations as well related to the similar kind of maths. So let's look. First of all, this is to review common values of trigonometric functions. You already have seen this. Suppose sine 60 degrees, root 3 by 2, this kind of thing. They are commonly used. That's why it is always good to review them. And one technique is always you'll find 0 degree 1 by 2, root 2 by 2, root 3 by 2, 1, then 0. You will see that up until here, they will actually start coming back. You see, this is 1, this is 1. Then root 3 by 2, this is root 3 by 2, root 2 by root 2, this is root 2 by 2, this is 1 by 2, 1 by 2, and this is 0, this is 0. So sine and cosine, they just corner, okay? If you want to keep that in mind. And this is 0, this is root 3 by 3, or we can say this is 1 by root 3 also, that also works. Then 1 root 3. You can think it this way also. See, sine divided by cos, tangent actually comes from sine theta divided by cos theta. So you see, this is root 2 by 2, this is also root 2 by 2. So if we divide root 2 by 2 and root 2 by 2, we will get 1. Okay, this way also you can find out this line. And these are not defined because 1 divided by 0 comes, divided by 0 whenever we see that thing is actually undefined. Same thing with this one. And we this 1, 0, minus 1, this is for 3 pi by 2, pi by 2. These values actually we can easily get from the unit circle. Concept of unit circle actually helps us the most to find out this sort of answer. For 0, pi by 2, pi, 3 pi by 2. They are the, in the step, let me show. They are just right at the, so if you draw some unit circle, this is actually 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is, in the unit circle, this is 1 comma 0. So actually this is 0 comma 1, this is minus 1 comma 0, this is 0 comma minus 1. So this line, this line easily comes from the unit circle. So if you just refer here to there, this actually helps for you to keep the things in mind more and more, and to solidify your learning. Actually, if you cross-reference figures and the values, then it works. These are also, of course, comes from the unit circle, uh, as you know. All of them actually we can derive from unit circle. So let's go to the next one. This is another important concept about in which quadrant sine is plus, in which quadrant cos is positive, this kind of thing. Okay. In our first, so the quadrants are counted this way in the counterclockwise. This is our initial initial line. As you know, when we discuss the angle, we always said that this is the starting side, and then terminal side is this one or that one, wherever we draw. So in the first quadrant, this is the first quadrant. In this first quadrant, this is C. This is number 1 first quadrant. The second quadrant is here, not this way. We always go counterclockwise. So this is convention. So first one is first quadrant, second quadrant, third quadrant, and fourth quadrant. In our first quadrant, all of them are positive. Sine, cos, tan, cosec, sec, cot, all of them are positive. In the second quadrant, sine and cosec is positive. Sine and cosec is positive. Others are negative. Others means suppose cot theta is negative and other values are negative. In this quadrant, tan and cot negative, and in this quadrant, cos and sec is negative. And why they are so? Suppose if you say that why they are negative in some quadrant, why they are positive in some other quadrant, if you draw some unit circle, it will start making sense. As you know, on the unit circle, suppose if you think about any value here, any value, suppose some random value, what can be the value here? This coordinate of this point can be what? What can be the coordinate of this point? So whatever the coordinate of this point is, since it is the radius is total 1, of course, then we can find it out. But just let's look at the sign. You see the x value of this point will be negative, y value of this point will be positive. This point's y value will be positive. Okay, so x value of this point is negative. That means what? That means this value, first value is cos. First value is the cos, second value is the sine. So you see the value of cos will be negative. The value of sine will be positive. Sine theta will be positive in this quadrant. Since on the unit circle we know the value will be what? We know it. So this sine is positive, and you know sine and cosec, they are actually reciprocal of each other. So if sine is positive, then cosec is also positive. And we know that the first value is sine theta. We have to give a theta here. Okay, then this theta comes. So cos theta is negative. If cos theta is negative, you see sec theta will also be negative, because cos and sec is reciprocal to each other. At the same time, if either sine or cos is negative, then tan theta will also be negative, because tan theta actually comes from sine theta divided by cos theta. So tan theta will also be negative. If either of this sine or cos is negative, then tan is also negative. That's why we know that this is how it comes. Only in this box sine is positive. And similar concept, similar kind of consideration you can actually do for other boxes. And for all other boxes you can think about this. In this box, both sine and cos both is negative. See, negative, negative. That's why tan is positive, because negative sine divided by negative sine, they cancel out. They cancels out, so that's why it happens. And this is the summary of what is discussed here. In the first box, sine, in the first and second quadrant, sine and cosec, they are positive, and cosec and sec, where they are positive, this and this, tan theta corner, so they are positive. In the first box, all of them are positive always, because as you know, in the unit circle, whatever this value is, sine value and cos value, both of them are positive. So if sine is positive, cos is positive, then their reciprocal cosec and sec is also positive, and eventually from the calculation, tan and cot is also positive. So the discussion, this kind of thing, we will be discussing again and again from different class to one class to another class, because these concepts will actually starts coming back and again and again. And this concept will be useful for solving one math. I have given one optional math. If you look at the last page of this slide, one optional math, which is 131 number. For solving 131 number, this concept will be needed. And also we will need this concept for our next section. So I thought that we can discuss it little advance, which means that we will discuss it once again in the coming classes, of course briefly at that time. And if you ask question, then we can discuss it in detail also, no problem. This is one actually easy question, this kind of problem. Sine 28 equals to what? Like you will be using the calculator to find out the answer. And we have to write our answer into 2 decimal places. The question is use the calculator to find out the approximate value of each of the expression and round it to 2 decimal places. So suppose sine 28 equals to what? So sine 28 equals to 0. There will be a lot of sometimes this equals to, it comes 0.469 etc, 469, still some more digits. So they said that round it to 2 decimal places. So 2 decimal places means 1 2, we have to keep it 4 6 or 4 7, just 2 digits. So if we just round up this one, the rule is, suppose we are rounding up to 2 decimal place up to here, since next digit is more than 5, the rule is if it is 5, if next digit is 5 or more than 5, then the previous digit, this one, we have to increase by 1. So this means that our answer will be 0.47. So why this 6 became 7? Because after 6 we have 5 or more than 5. 9 is more than 5. Now suppose, just suppose this value is 0.464, then our answer will be, I think, I'm sure actually most of you I think know this. If you don't, just this is how it comes. Okay, so suppose this kind of math, this one, cot pi by 12. So cot pi by 12, how can I do? We can do it in 2 ways. One is you can convert it. This is actually given in radian, so from the radian we will convert it to degree, because that's convenient. Or if if your calculator directly works in radian, we can actually, there are some functions you can just have to press the radian. But we will now convert it to degree, and then we will do it, since that's the way you have learned it, more or less. So this is cot, but you see this function, this calculator, this kind of calculator do not have any cot function. Only have sine, cosine, tan. This kind of calculator, sine, cos, tan. And most of the calculator actually is like that, sine, cos, tan. So we will convert it to tan, then we will do this math. So first of all, if we convert it to 10, we can actually keep this. Then it will be 1 divided by 10, whatever the angle is, 10 pi by. So pi means 180 divided by 12. 180, pi means 180, then divided by 12. So we get 15 degree. So total value is, here it is 15. So 10, 15. Okay. This pi by 12 means 15 degree. Now we will do 10, 15 degree equals to what? So 10, 15 degree equals to this. 10, 15 equals to this. Then 1 divided by answer. 1 divided by whatever it is. So we get this 3.73. And you can see after 3.73, the next digit is 2. So we do not have to add anything. So it looks like we are approximating this one also. So the answer is 3.73. So the answer is like this. Then sine 1, tan 1, they are reasonably easy. If cosec, we have to convert it. We will convert it first to sine, then we will do the math, etc., etc. This is 10 pi by 10, that means 180 divided by 10. First of all, we will convert this one, then 10 function, we will use it in the calculator. And if there is some more thing, suppose if this is tan 1 plus cos 14, cos, this is just only cos, suppose cos 14 degree, so 14 degree, then hey, this is actually in radian. Okay, these are in radian. How do we know that these are in radian? Because see, this is degree is not given, that means it is in radian. So you can convert it, suppose pi radian. We have the formula, or 1 radian equals to what? You know that pi radian equals to 180. Then 1 radian equals to 180 divided by pi. So 180 divided by pi. That means this, instead of this 1, you have to put 180 divided by pi. Pi means now here 3.1416. You can put here. Then 10, whatever this is, that value equals to what? That will be the answer for this kind of case. Because this is in radian. Okay. How do we know? Because the degree sign is not given. See here, degree is given, degree is given, degree is given. Degree is given even here also, but no degree given here. If degree is not given, then it must be in radian. So yeah, so we can convert it to the, so this math will be somewhat like this, 10 this is 180 divided by pi, 180 divided by 3.14. We can keep up until here. So 57.7, 57.32 degree. I'm just saying, then plus cos 14. Suppose this kind of big math, 2 or 3 math is combined, then what you will do? Cos 14 degree. This is in degree, let's say. I actually have taken this value from here. I'm just saying this is another math. This kind of, we can actually combine the terms and make a bigger math. Now this part is easy. We can just put 10, 57.32 degree plus cos 14 degree. Just we can press equals to what? Whatever it comes, that should be the answer. See, directly we are doing it directly. 10, 57.32, then cos, that is. So answer comes 2.53. 2.53. So that's the answer it comes. So this way, this kind of approximation and rounding, we can do this kind of maths actually this way. These are approximate value because after this there are some other digit. After this there is some other digit, or we rounded it actually a couple of digits. We truncated couple of digits to get up until 2 decimal places. So here are the application math. This is from the book, and this one is from the book. You can see this is the setup of the math, setup of the question, whole question. For some projectile motion, the function for r and h is given. R means the range, total range from starting to the ending. This is the range, and function for the h is given, height. How much up it will go. That is the function for height. So the question is given here. This is the entire thing is the setup, and we will not have to do anything to derive the function for the range or function for the height. Our question is given here. They said that, okay, if the projectile is fired, projectile means this object, this is called the projectile. If I throw something, that will be the projectile. Suppose if I have this, and if I throw it, then it will be a projectile. If you throw something curve in some curve way, then it just go like this and then fall. This is a projectile. So a projectile is fired at an angle 25 degree to the horizontal with an initial speed of this per second. So how do we find out the range and the height? So we just have to put the value here. The theta is 25 degree. So the theta is 25 degree. 25 degree is the theta. Given theta is 25 degree. This theta. And the velocity is given 500, so we have to put 500 here and this. Similarly, we have to put the 25 here and 500 here. So if we put it, see this 500 and then 25 into 2, because there is a 2 here, 9.8, 9.8, then we get this value. Now you see G, the value of G is 9.8 here, because this is given here 9.8 meter per second. Also, this math is meter per second related math. There is two value given for G. One is 32.2 and the other one is 9.8. So why we are using 9.8 without using that? Because this is feet per second. This is feet per second, and the next math is actually about feet per second. So for the 124 number we have to use this value, but for 123 number math we have to use this value for G. Since the unit, we have to match the unit, since the unit is in meter. Okay, G meter, that's why meter per second per second. So we just have put the value in this function, and this is the remaining thing is just calculation. Sine 2 into 25, you just do it in the calculator. 2 into 25 means sine 50. So sine 50 equals to 0.7, see 0.7660. So I have written 0.7660. Then there are some other digits. I just thought, okay, 4 digits should be enough and sufficient for this calculation. And 500 square equals to 25, then 0.0000. This is the calculation, and if you do the calculation, it should come here. Same value for the first math, because we are solving 123 number here. So same value, but the function is different. This is b square, then sine theta whole square. Okay, sine theta whole square. So if you do the calculation, sine theta whole square means this, 500 square means this, 2 into 9.8 means this, then you just this into this divide by this. So you can just easily do it in the calculator. And I have done this math 124 also. So in the next page, it is 124. This is the answer for 124. So you see, for this math, since this is feet per second, see 200 feet per second, that's why we have to use 32.2 feet per second. This the value of G will be this one. Same function, same methods, just the value is different. This is 200 instead of 500. Now it is 200, so it is 200 square. Then sine 2 into whatever the angle is given. Angle is given 50 here, so we have to write 50. So let me check. Sine 2 into 50. So I think sine 2 into 50. Sine 2 into 50 equals to, or I can just do sine 100. Sine 100 equals to 0.9848. 0.9848. Let me square it. What comes? 0.9698. So I think it looks like there is a, yeah, there is no square here. Yeah, there is no square here, so 50 square. So if we write sine 100, sine 100, 15 to 2 sine 100, then b square means 40000, then it comes this divided by 32.2. 32.2 is the zero of g, so answer comes 1223. Hey, so by mistake I have given I square here. There is no square. Okay, so I will do the correction in the slide when before posting it in the Google Classroom. But since this is in the video, so let me put the correction here. So this value will be changed and the answer will be changed. Answer is 1223. 1223.36. So and sine 100 means 0.9848. This means 0.9848. This means 0.9848. Sine 100 means 0.9848 and more. I'm just taking 4 digits. And the other thing is looks good. So this will be the answer. Okay. And this part, so v naught square, that means this is the value 200, so 200 whole square, then sine 50 whole square. So sine 50 whole square means sine 50 whole square, sine 50 then equals to then whole square 0.5868, 0.5868, that's good, then into 40,000. So this then divided by 2 into 32.2, 364.49. Yeah, that's good. So that's correct. So this is how we can do this math. There is no square actually in the function. In the given function, there is no square. So there will be no square. Yeah, we just have to put the value and do the calculation here and make sure that we are not giving anything from ourselves. Yeah. Let's go to the next one. So we have more application maths. This is another one. So in this question also, our designer of decorative art, you can read the question. Whole question is the setup for this math. Our function is given volume. For the volume, the function is given p of theta equals to 1/3 pi r cube 1 plus sec theta whole cube divided by tan square theta, tan theta whole square. So this is the setup. So and they asked us what will be the what volume v is required to enclose a sphere of radius 2 cm in a cone whose slant height angle theta is this. This looks like a crazy math, okay, based on the question and etc. But if you read if you read this part, what we have to do is given here. We just have to put the value of v. This is the radius. We just have to find out. We have to find out the volume v, and radius is given 2, r equals to 2 given, and angle is given one math 30, another math 45, another math 60. So basically our task is to put the value here and just do the calculation. That's our task. Okay, so we can do it because the objective of the chapter of this maths is to find out your calculation skill and using the values, like how to do the calculations with the trigonometric different angles and etc. That's the reason. So since the r equals to 2 is given, we just have to put r equals to 2. So if I put 2 here, 2 cube means 8. That means 8 divided by 3 pi. This is just some simplification. You can just do it directly here also. But we just have put the 2 first. Then for 30 degree, we have to do the calculation. See, just we have to put 30 here and 30 here. Angle is now 30. The remaining thing is just calculator. Sec 30 whole square. So sec 30 we do not know. Then what we have to do? We have to go for cos 30. Cos 30 means what? Root 3 by 2. So sec 30 will be 2 by root 3. So 2 by 1 plus 2 by root 3. Then whole cube. This is tan 30 whole square. Tan 30 means 1 by root 3 or root 3 by 3. that also is possible. Just put it here and the whole square it. The value, what I am doing is I am just saying the values, and we just have to put the value and do the calculation. Answer should come this, and this, since this is volume, so centimeter cube, and we understand it in another way, that is this is 2 centimeter, so we put 2 centimeter here, and there is a cube, that means centimeter cube. So this way this centimeter cube comes. Similar kind of approach, 45 degree we put here, then we just put the value of sec 45 degree, then tan 45 degree, and just do the calculation. The answer should come as it. And if anyone have problems in these calculations, please feel free to tell me during the class. I will elaborately will try to solve them. Okay, we'll try to do these maths elaborately. I mean the calculation part if you need. Okay, another just one question, just simple question. This is given as some limit 0 degree to 90 degree. My question is why this has to be true, why it is given 0 degree to 90 degree. What's wrong if it goes beyond 90 degree, or if it is less than 0 degree, what happens? Think about it, and if you get some solution, let me know during the class. This is another math. We will not have to solve this math, but let's discuss how this formula came from the. This is our example number 8 from our book. Example number 8. So in the book, they actually gave this question, and a of theta equals to 16 sine theta cos theta plus 1. They gave this question, and they said that if theta equals to this and that, then what will be the area? And so look at this. If you see how this formula they got. If you look at this figure, you will see that they said that this value is 4 inches, this is 4 inches. They said that constructed 12 inches total, okay, wide. After making off a length of 4 inches from each edge, so if you take 4 inches and 4 inches, the length, then they make the angle. So as they said here, so 4 inches here. And the angle is given, theta is given here, theta is given here. So if this is not important, by the way. We are just explaining this. If you are curious about different maths, this is how they get their question. How they get the question. This is what we are discussing now. So, and you will not be asked during the exam or any time that okay, now explain how they get the question. Okay, this is a bit simpler. That's why we are discussing, and kind of related to triangle and simple concepts. So it's good if we discuss. So you see, in this figure, if you look at this is the hypotenuse. If we think about that, this is angle hypotenuse, and we can draw some angle here, perpendicular line here, okay? Or we can transfer this theta from here to here also. Then we can find out the other things. So our base, this base will be, the base will be 4 cos theta, since you know from our formula from SOHCAHTOA, we can actually find out the base will be 4 cos theta, and the perpendicular side or the opposite side will be 4 sin theta. Similar thing for this picture, similar thing will be here, because they are actually same figure in the both side. So the downside will be 4 cos theta, and this is 4 sin theta. Angle is here. Angle is here. Theta is here. Angle is here. This angle is given here, but if we need, we can actually transfer this angle to this place. Then this will be the angle, because these are the alternate angle. So alternate angle are equal to each other. Alternate angle and corresponding angles are equal to each other always. So we can actually transfer this angle and this angle. So they will be actually they are the same triangle, just divided by this line. Anyway. So if we break it down, then this side becomes 4 cos theta, this side becomes 4 sin theta. Similarly, this side becomes 4 cos theta, this side becomes 4 sin theta. Now, since it is a triangle, what is the area of the triangle? Area of the triangle is half into base into height. So it is. So area of the triangle is half into base into height, and half into this. So it will be, see, 4, 4, 16, 16 then into half. That means basically it will be 8 sin theta cos theta. 8 sin theta cos theta. And from this figure also, Another 8 sine theta cos theta will come if we try to find out total area. So, and if we add these two figures, this figure and this figure, then it will be total 16 sine theta cos theta. Sixteen sine theta cos theta. And in the middle, if you look at what is the area of this box here, what is the area of this box here? You can see this side is actually 4 sine theta. Already we know, because this side is 4 cos theta, so this side is 4 sine theta. This way we can consider. This is the opposite side of the theta. Opposite side of the theta is sine. And this side is 4. We already know because they said that total was 12 inches, and then 4 gone here, 4 gone here. So this must be 4. Remaining 4. So this is the 4. So now you see we have 4 here, 4 this side, and this side is 4 sine theta, which is given here, 4 sine theta and 4. So this into this, if you multiply, since it is a rectangle, 4 into 4 equals to 4 into 4 is 16, so we can write plus 16 sine theta. Now what about if you take the 16 common? So if you take 16 common, if you take 16 sine theta common, because sine theta is also common, then we get cos theta plus 1. Then we get cos theta plus 1. And this is the question that they gave us to solve. So if you go to this math in the book, example number 8, you will see that they will not ask you to find out how this formula came. Their question is find the area of the opening for theta equals to 30, theta equals to 45, theta equals to 60. Means if you put theta equals theta value 45, this 30 for first math, you will get the solution. But this is just how they got this question. Okay, so this is how they got this question. But the math is easy. I think by now you know this is sine 30, you put here, 30 you put here, then do the calculation. You can use the calculator, or you can, if you are expert in manual calculation. We prefer, as long as you can do manual calculation, do it by manual way without using calculator. But there are some cases where calculator is perfect, completely okay, no problem. Calculator, there are cases where we have to use that at this point. Yeah, but if you have time, then of course there are always ways to do manual calculation. It takes time, it takes time. These are the practice homeworks, and the question number 85 and 87. These are application math is this, and 85 and 87. Oh, these are the maths from finding the approximate value when 2-3 approximate values are together. Okay, so you can give a try. Not too hard. They are not too hard. And optional math is page 131. This 131 number. Page number is 379. Page number is this. This is the page number. And from the optional math, yeah, if you have questions in any of these maths, we can discuss it during the class time. But before class, you can give a try to solve these maths, and I think that will be a good idea. This is another from 6.3. You can try to read from the page number 380 to 385, focusing on periodic properties and finding exact values of periodic properties. These are not for this class. These are for next class. I will of course make slide for these topics as well. Of course, they are coming up. So that's all for this moment, and thank you everyone. See you all in the class. Bye bye.